Hey guys, what's up? This is Steve. Today let's go through LeetCode problem 1620, coordinate with maximum network quality. Let's take a look at the problem description first. You're given an array of network towers and an integer radius, where towers I has these three elements, xi, yi, and qi. What do these denote? They denote the ith network tower with the location xi and yi with quality factor qi. All of the coordinates are integral coordinates, so they are not float or double points. On the xy plane, so it's a 2D plane, which gives the definition, the boundary of this problem. And the distance between the two coordinates is the Euclidean distance. How do we calculate Euclidean distance? We can simply Google that if you're not familiar with that later on. Then let's continue, go through the problem. The integer radius denotes the maximum distance in which the tower is reachable. The tower is reachable if the distance is less than or equal to the radius. Once outside of the distance, the signal becomes garbled and the tower is not reachable. So then let's take a look at how it defines signal quality. The signal quality of the ith tower at a coordinate x and y is calculated with the formula. It takes the floor. This is the symbol of floor in math. Qi divided by I plus d. What is d? D is the distance between the tower and the coordinate. So the network quality at a coordinate is the sum of the signal qualities from all the reachable towers. So here is the definition of the signal quality. It is the sum of all of the coordinates from all of the towers that are reachable to this coordinate. All right, it's kind of lengthy, but every single word statement here is part of the definition, so you don't want to miss anything of this. And then it's asking us to return the integral coordinate where the network quality is maximum. So we want to find the network or the tower just given from the given API signature is the first parameter is a 2D array, which is called tower. And how many towers are there is towers.length, right? So the answer is just in one of these towers coordinates, just x and y. That's the final answer that we want to return. Which x and y is the correct answer? That's the one that we want to return. So it also says that if there are multiple coordinates with the same network quality, which are the highest, and then we want to return the lexicographically minimum coordinate. All right, let's take a look at the problem. So it also here it explains what is lexicographically minimum coordinate. See here, if a coordinate x1, y1 is lexicographically smaller than x2 or y2, if either it's x1 is smaller than x2, or if x1 equals to small x2, but y1 is smaller than y2. That means x1 and y1 is lexicographically smaller than x2 and y2. In this case, we should return x1 and y1 instead of x2 and y2, assuming both of these two coordinates, they have the same strong quality signal. All right, now let's take a look at this example. So we're given these three towers. So the first two are x and y, right? So 1, 2 is 1, 1, and 2. And 5 is the signal quality strength of this one. So it's at 5. This one is 5, right? So we see here 1, 2, 3. These three elements, the first two are the coordinates on the x and y plane. So the second tower is 2 and 1. 2 and 1. Quality is 7, so here is 7. So the third tower is 3 and 1, 3 and 1. Quality is 9. The output of this, which coordinate, which tower and which coordinate has the strongest signal total sum, right? Which one? So it's 2 and 1. Why is this? Just based on looking at this graph visually, we can tell it should be this one because this one is right in the middle. This one has a radius, this one has a radius itself, this one has a radius as well, and the radius is 2. So we can tell it is this one, 2 and 1. And how do we reach to this conclusion? We can visually take an educated guess. Once there are too many towers and once we need to write the program, we cannot guess, right? That's not how programs work. How did we reach that conclusion mathematically or programmatically? Here is the calculation. So at coordinate 2 and 1, the total quality is 13. How did we get 13? So first, quality of 7 from 2 and 1 is the results. 2 and 1 is itself, right? 2 and 1 is itself. So how did we get the signal quality from this tower itself? we still follow the same formula. We take the floor of the signal quantity 7 divided by 1 plus the Euclidean distance between this one and itself, which is going to give us 1. So that is why the denominator has a +1 here. That is to exclude the possibility that 0 might be the denominator, which is going to give us runtime error in programs, right? And it's going to invalidate the result of this tower itself. So let's see. So 7 divided by 1 is 1. So which is the signal strength of itself, which makes total sense because you are getting the signal strength from your own tower, which is your own signal quantity, right? Which is 7. And then let's take like quantity of 5 from this tower, 1 and 2. How do we get the strength of this tower at this point? So we get it by following the same formula. So 5 divided by 1 plus square root of 2. What is 2? How do we get 2? That is the Euclidean distance. Let's see. If you're not familiar, we can just quickly Google this and see Euclidean distance. So this is the Euclidean distance. It is the sum of all of the x and y coordinates, the difference of them. So x1 minus y1 times itself, and then plus, since this is a 2D plane, we only need to do x and y, right? So then times x2 minus y2 times itself. Then we take the square root of this. That's going to give us the Euclidean distance. That is how we get to the 2. Because see, 2 minus 1, that is 1. 1 times 1 is 1. Then 1 minus 2 is minus 1. Minus 1 minus 1 times minus 1 is going to give us a 1. So 1 plus 1 is 2. That is y2 is here. Then we take the square root of 2, and then we take the floor of this is going to give us 2. So this is how we get the signal strength at this tower from here, right? So this is how much the signal strength is from this tower and this tower's coordinates. The same case, we can apply the formula to calculate the signal strength that is coming from this tower and this coordinate. So we get it 4. And then we add up all of the signal strength, which is 7 plus 2, that is 9. 9 plus 4 is 13. So we get 13 here. That is how we get the signal strength of this tower's coordinate, which is 2 and 1. Similarly, we need to calculate the signal strength at the other 2 locations. And then we do a comparison. We return the largest. If there's any tie, we return the lexicographically smallest tower. Hopefully that makes sense. This, if you can understand, you walk through, you just follow the definition, the context of this problem is very straightforward to sort this problem out. And then the idea of solving this problem becomes very obvious, right? We can just go through every single coordinate, every single tower's coordinate, and we calculate the signal strength of every single one of them. And then we maintain a global calculator to update the max. And if there's a tie, we'll just return the lexicographically smallest coordinate. That's it. So the key here is that you want to understand the problem. Nothing is really difficult after you have gone through, you have understood the problem. The solution is very straightforward. We just have a for loop. By calculating the Euclidean distance, we get the signal quantity. Then we add all of them up to get the signal quantity at this particular location. And then we keep updating the global variable. Now let's put the idea into the actual code. So here, first we want to have the final result, we'll just call it best. It's an array that has only 2 elements, right? So now next, we want to go through this towers array. Towers length I++. So first, we want to calculate the distance. And before we go here, we would like to have a global variable. We'll just call it max signal. First is going to be 0, and then we keep updating this if we encounter a higher signal strength, right? And then so here we'll maintain another variable called quality. I'll just call it this quality, and then we'll just keep calculating the signal strength. We need another for loop. Int j towers length j++, and then from here we calculate each of the tower's strength at this i's position, right? First, we'll calculate the distance. We'll just calculate the distance from this tower at j's position to the tower at ith position. All right, let's do it. Math square root. How do we do this? So then inside this, we would like to get towers i's first one minus towers i's j's. All right, so this is going to give us, we need to time this. All right, and then what we need is, this is just an x1 minus y1. Then we need to x2 minus y2. All right, let's do that. Let me, I don't need to copy this. So 1 and 1. All right, now let me copy this. We need to time itself. All right, now, yeah, we time it by itself. And then next step, so now we get the distance. So next step is that, let me just move this up a little bit so that it's easier to see. Still not very easy. My screen is not wide enough. Now, next step is that we want to make sure that the distance is within the range of radius, right? So if it's out of the range of the radius, that means the signal becomes garbled. That tower is not reachable from this coordinates. If it's within, that means it's less than or equal to the radius, that is reachable. So we want to calculate the signal strength at this tower's coordinates. And after calculating that, we want to add that up to here. So how do we calculate that? So in Java, there's a floor function, which is very convenient here. And then the definition here is Qi. So let's get Qi, towers I and 2. So this is the third element in this given towers array, right? So 0, 1, 2. 1 and 2 is the x and y coordinates. So 2 is the quality. And then we're going to divide that by 1 plus distance. This is this quality. After getting out of this for loop, we can check if this, let me just copy this. If this quality is greater than max signal, in that case, that means we have encountered a new towers coordinates, which has the stronger sum of all of the quality signal qualities. Then, of course, we're just going to update the result, right? Which is going to give us towers I and first one, and then best. That is the second one. This is going to update the result. The other case that we need to take care of is if there's a tie, we want to make sure that we return the lexicographically smallest minimum coordinates. So that means we need to check if this, else if this, if this quality equals to max signal. And then in this case, we want to make sure that we do update the result if this one is lexicographically smaller. So let's check. If towers I, so the first element of this towers I is going to be the x coordinate. So if we want to check if this one is smaller than best 0, right? If that is the case, we should update it to be this one's towers i's and 0, and also its y element. That means we found a smaller one. Otherwise, if x coordinate is the same, but the y coordinate is smaller. Let's see. Y coordinate is smaller, right? This means the y coordinate, the current one, is actually smaller. So that means we still want to update the result. Then we'll just do the same thing. We'll just copy this to here. So of course you can merge these two else if into one put in an all parameter in between. That's totally fine, but I just want to write it this way to give it a more straightforward look. So in the end, what we want to do is that we can just return best. That's it. Now let me hit run code. Wrong answer. Let me take a quick look. So first we have a for loop. We use I to go through every single tower. We have this quality. Next we have a j. We calculate the distance between any one of them. And so here then we get this. Oh, this should be j, because this means, so we go through, we set I to be the one that we are calculating the power strength for, and j is the one that keeps floating around, right? So here it should be j. How do we calculate the distance? This is qi, should be j. Now let me hit run code again. It's still wrong. Why? Oh, I see. So after we compare, if this quality is greater than this, then we need to update this max signal. We need to update this to be this quality, right? Because it needs to be updated. Let me hit run code again. All right, now it's accepted. Now let me hit submit. All right, finally it's accepted. Yeah, this is the entire algorithm to solve this problem. So if you just spend some time and sort out the actual logic or a definition or the context of this given problem, although there's a lot of text to read, it's really straightforward after you have sorted out, and the algorithm, the actual code, is pretty straightforward as well. So I hope this video does help you make sense of this problem and also the solution. If that is the case, please do me a favor and hit the like button. That's going to help me out tremendously and I really appreciate it. Also, please don't forget to subscribe to my channel, as I have accumulated quite a lot of different LeetCode tutorials or data structure or algorithm videos to help people better understand and prepare for their upcoming coding interviews, or just to lay out a better solid CS foundations. So hopefully I'll just see you guys in just a few short seconds in my other videos. Thank you very much for watching.